Hello, we are the Active Radar Obstacle Detection Team. Supporter, mentor, and member information can be found at the top of the poster. The objective of our project was to develop an obstacle detection system for Active's pre-existing robot. In order to complete this, we need to write firmware for custom sensor module communication, as well as design an enclosure for custom sensor boards, determine the optimal sensor height and position, as well as to develop a GUI that will display an obstacle's location.
The ROS TotalBot used to provide a pre-made testing platform to test the autonomous functionality of the active radar boards, such as moving and driving. The Acuneer sensor used here is the XM112, as shown below in Figure 2, that sends radar pulses to detect and recognize object speed and distance that are used as an input for the TotalBot base.
For optimizing the sensors, we ran a simple test where we had an object slowly move towards the sensors. We looked at the visualizations of the radar shown in Figures 3 and 4 to find the efficiency results. Each test had a varying pulse length from short, medium, and long, and a pulse frequency range of 30 to 40 hertz. We found that a medium to long pulse length with a 30 to 35 hertz frequency range had the best efficiency with minimal noise.
Figure 5 is a block diagram showing the connection methods we plan on using to bridge the sensors with the TotalBot. As you can see, there is a proprietary connection between the sensors and breakout boards. From there, we use an SPI connection to connect the breakout boards to a CAN breakout and CAN analyzer. A USB connection is used to pull together the CAN analyzer and a notebook PC. The PC then communicates with the Kabuki base on the TotalBot through a USB connection. These connections were picked for their effectiveness and efficiency.
The TotalBot system is the first of 2 enclosures for our project. This system will only be used to collect test data and optimize the sensor's height off the ground. This is meant to be a modular system to learn the ins and outs of the sensor before its final implementation. The second enclosure is for Active's robot. This enclosure mounts to the inside walls of the robot and will be daisy-chained with 10 other radar sensors. This housing is optimized for its environment based on equations from Acuneer and will be used in the final implementation of Active's robot.
And for the future task of this project, we'll be 3D printing the enclosures for these sensors and write a firmware for these sensors so that the program will output the object locations. Thank you.